All right, so my name is Sam, as Jay just said. So I'm a product delivery consultant. I basically help companies by building them delivery pipelines. So we do continuous delivery.
A little bit louder, if you don't mind.
Sure. So I help companies do continuous delivery pipelines, which means I coach the businesses, I coach the developers, testers across the whole stack to do this. So these are some of the people that I've worked with in the past. Some of them have done continuous delivery very well, and some of them have done it really badly. And the ones that have done it really well are the ones that have done test-driven development. So I'm actually a testing geek, and this is what this talk is about. So first of all, test-driven development 101. Who here has done TDD before? All right, who here has done TDD with Meteor? Wow. Who here has done acceptance test-driven development with Meteor? There you go. Right. So the fundamentals of any testing are basically that you do setup, execute, verify. So if I want to test, say, a user preferences form, my setup would be to log in and to navigate to the preferences form. Then my execute would be to say change a value, and my verify would be to see that the value changing has had an effect. Sorry? Has had an effect on the screen. So the typical developer workflow is that people write some code, and then they run it, and then they have an expectation. So then they check the expectation at the end. Now, with test-driven development, that workflow is slightly reversed. So what you do is you have your expectation first, and then you write some code to fulfill that expectation. And then after that, you run it, and you see if everything's okay, and you may have to go back and revise your expectation a bit. But the point is, every time you write an expectation, you're basically bracing your code and making sure that in the future, any changes will be highlighted. So I'm going to go and do a very quick 1-minute example. You can see here, this is a hello world. I only did yo world because it wouldn't fit. Otherwise it would have been hello world. So you can see that the first thing we do is in the setup is spy on the console log. And then we run the main code, which is this amazing line here. And then after that, we expect that it should have been called with yo world. Now this one's got a typo, it will fail. So then we go back, modify the code to not have the typo, and it will pass. Word of advice, you should never use copy-paste because of exactly this reason between your test and the code, because you could copy a typo and you would never know. Right, so that's a quick TDD approach. The other thing to bear in mind about TDD is the test boundaries. So any piece of code or any software is made up of a lot of units that live across the whole stack in different tiers. Now, when we talk about unit tests, that's what we're talking about. When we talk about integration tests, we're talking about units that talk to each other, but not quite all the units, and they can also live across tiers. And when we talk about end-to-end, that's what we really mean. So when you're doing unit tests, you want to isolate. And isolating means you want to mock and stub everything around that unit to make sure that you're only testing that unit. When you're doing integration, it's exactly the same thing, but you stub anything around the integrations you are testing. So in this example here, it could be a unit of yours and jQuery. I'm personally not a fan of doing any integration tests at all. I just do unit and end-to-end, but that's just a preferences thing. So end-to-end also has external systems. So if this is your system and everything is end-to-end, you may have a dependency on, say, a mail server or something external. And you'd also mock and stub those in much the same fashion. So that's a really quick TDD introduction. You can spend a lot of time learning a lot about it. But the main question is why bother with it? These are a lot of good reasons. So the risk of success is often the one that's missed out, is that you come in, you've got a great idea, you start coding, it takes off, suddenly you have to grow, and now you're coding away and the stuff that you've done before is no longer protected. So really, the best approach if you're a hacker, if you're just getting started, is to always question, is what I'm doing valuable? Has it become valuable to people? The minute it's become valuable, that's the time to go and protect it with tests. Or even rewrite it in TDD. If you're spending somebody else's money, you can do TDD the whole way. So yeah, these are some good reasons. The other thing I think is it makes you a better developer, and it gives you basically a seatbelt. So if you fail, you know that you failed. Right, so now we're going to go into the meaty bit, which is TDD with Meteor. So the first thing is that in Meteor, the reactivity really messes with the DOM. So in a test, you want to go and check that things are happening on the DOM, but then it would have changed because that's how Meteor works. So what we used for this, to solve this challenge, was basically SELENIUM WebDriver. Selenium WebDriver has been around for a long time. The WebDriverJS has a promises API, and that works really well with reactivity because you can basically have a promise, and then it's only fulfilled once the DOM has changed. So we'll go into an example in a second, but the other thing the WebDriver has is basically it's got support for Chrome, Safari, etc. So you can build out a farm of testers, excuse me a sec. Basically, you can build out a farm, and if you've got like a really big code base, then you can test it really quickly. It's also open source, and there's massive community support. So, some people will know this this example. It's basically the leaderboard application in Meteor. You select the player, you give it 5 points, and it'll move up. Excuse me. So you'll notice also we've added on here the a login. And the reason we did that is so that we can test login functionality. So the first thing we do when we're defining a test is we basically define it in English, which is, in this case, it increases a player's score by 5 when the increment button is clicked. So the next thing we do is we write the user journey in plain English also. Excuse me, talking loud is really getting my breath short. Let me just calm that down a sec. Right. So, in this case, we write it in pure English. So we say first, we want to authenticate, then we want to find the player by name, and then we're going to verify their score is 10. Then we're going to select that player, give them 5 points, find them again, and make sure that their score is 15. So if you look at the code just for the authenticate, what you can see here is we use the driver find element, and it works by finding stuff by ID. And then we can say click it, write the email address, write the password, click on the link, do some more clicking, and at the end of it, we do get text, and this is the then function. So the next thing is we start using deferred objects. We create a deferred object, and when the authenticate method is called, the deferred object will, so this function will run very quickly, excuse me, and that promise will be returned. But the deferred object will only be resolved after the get text then has been fulfilled. And here we check to see if the email was not the correct one, then we reject the deferred object. This is how you basically handle DOM reactivity. Now that looks very easy, but sometimes it can get really tough when basically you've got promises within promises. So if you've got one promise, then you have 5 promises inside. If the main promise returns and you haven't returned the other promises, then you can get in trouble. So basically it'll just crash. So what you then use is this thing called a flow. And in flow you can control the order of the promises, the way that they're called. So that's how we got around reactivity in Meteor. So the next thing is that the code is tightly coupled to the framework. What this means is, when you start with Meteor, you start up in the application server. So that gives you Meteor, it gives you templates, handlebars, depths, all these things that you're used to using. When you run it as test code, you get nothing. You're just running a unit test that gives you no access to Meteor whatsoever. And so if you try and use anything like Meteor or templates, you'll just get undefined. So what we did for this was basically we created the Meteor stub. Now the stub does not provide the functionality of Meteor, it just provides you the ability to capture and isolate the code that you would normally use with Meteor. So this means that you no longer get undefined errors. It also, like I was saying, gives you access, so if you wanted meteor.startup, you can just grab that and run just that function. The other thing we've done is allow you to simulate events, and I'll show you an example of this shortly, on the templates. And then finally, any collection that you define in your main code will automatically get all the prototype methods on it so that you can spy on them. So here's a unit test example. Template.leaderboard.players basically is a function, and this should be quite familiar. It has a reactive data source. So basically it's doing player.find, and it's sorting primarily by descending score order and by ascending name order. So just like before, that's exactly what we write. We say it asks for the players primarily in descending score order, then in alphabetical order, and returns the cursor. So the first thing is we go to setup. In the setup, the stub that we've done allows you to create stubs for the templates, because if you try and access template.leaderboard by itself, it won't exist. So this template.stub allows you to create a leaderboard template. Now that we've done the first part of the setup, the second part is that players.find is not what we're testing. We're trying to test this function up here. So we set up this to return just a dummy local cursor. The next thing we do is we execute, And in the execution, we simply call that function. And in the verify, we basically ensure that the right parameters are set for the score and the name here, and basically that this is going to return the cursor. I said I'd give you an example of the events. I don't actually have one, but if you wanted to call an event on this one, this is how you do it. You basically say template.leaderboard fire an event, and that will call the code that you had used for your event. All right, so that's how we solved basically the tight coupling in this two-couple Meteor, and we're able to isolate the units of code. So finally, the loading order matters in Meteor, and especially when you're loading the stubs in unit tests first. Now, we use something called Karma Runner, which had a horrible name before, and basically it allows you to control the loading order of the files that you're loading. So the first thing we do is we load anything that we've stubbed. We've got Meteor stubs, we've got jQuery stubs, and then the next thing is to load the unit tests, because the unit tests, as you remember, will do things like template.stub, so that has to happen first. And then finally it will load the code in the same order that Meteor would otherwise load the code. And that's how we solved the three challenges, the main challenges that we had with Meteor. So what I've showed you is a really simple example. You can go to our GitHub repository, and there's an example called real-time development with Meteor. And this has the whole leaderboard code and a more complex example that you can look at. Right, so the other thing that we've been busy doing is doing something called RTD. We call this real-time development. Now, it's basically a delivery paradigm, and it's all about being really quick. It's about getting feedback as quickly as possible when you're coding. So there's a lot of, like Karma Runner, whenever you save the file, it'll give you immediately a test report. What we've done is we've extended that. I'll show you a demonstration in a minute. And you can have this basically today as a submodule. So you just go to our GitHub repository, add it as a submodule, and you can hit the ground running and start doing test-driven development. So I'm just going to flip into the IDE here, and what I've got is our code. I've got RTD running in here. In fact, I'll just restart it. So it's just a grunt file, and it does a whole bunch of things for you. And right now you can see it's waiting. So we've got a bunch of tests here that do some complex drag and drop, and so forth. All I'll do is I'll modify the file, save it. You see here it ran my unit tests. The next thing it's doing is it's firing up I'm just have to close one of those. Excuse me. There you go. It's fired off a browser, and it's running all my acceptance tests in the browser. Now the idea is that I got a failure because I probably did something wrong somewhere. So if I just go back and turn the number of sessions to 1. Just missed that, excuse me, try again. So here we go, it's waiting again. I'll modify the file. You should see open a window. Unit test ran. So it's doing all these bits. Now the interesting thing is that this is running on port 8000. I can open up my other browser that's currently running in full screen, and I can go to port 3000. And I can still be using my main app and doing stuff on my main app. And then let's say I go in here and I mess it all up and I get rid of a main line of functionality. So I still try to use my app, and you'll notice over here I've got a failure saying the test running in the background in that hidden window are showing me a failure. So even though I'm coding, I'll get this, I'll come back, have a look, and go, oh, I've done something to mess my code up. So I'll be able to go and correct it there and then. And this is what we mean by real-time development. So if I go back to the main window, wherever I put that, let's go back to the presentation. Sorry, I've lost it. I'm actually done. This is the last slide. Right to the end. So basically that's it. You can use this today to start doing test-driven development and get all the niceties we've put in. You can ask us questions and we'll answer on our blog. And we do need your help because RTD is really quite young and there's a lot to stub still. So the more that people commit and add to this, the better. And I actually forgot to show you something completely, which I really think I should, is once these tests actually pass, it will generate a coverage report of my tests. So I'll show you this. Give it a second, they're running, yada yada yada. So far so good, they've passed. The next thing it'll do is it'll fire up this page, which is basically a coverage report. This coverage report is a combination of my unit tests, my code that's on the server, running on the Meteor server, and also all the code that's running on the client. And it takes all of these and it combines them into a single coverage report, And so I can go into my code and I can see that basically I've managed to cover everything. If I miss anything out, it'll come back as red and it'll highlight to me that there's something wrong. And that's it. Any questions?
I have a question.
Hello.
So you said that one was on 3,000, one was on 8,000. So
Yep.
are there two separate Meteor instances running?
Yes.
Is one doing the testing and the other running the actual application?
Exactly that. Every time you save a file, it completely synchronizes with the mirror application, and then it runs the tests on the mirror application. The reason we do that is because acceptance tests are quite destructive. So at the beginning of every test, we hit a clear state, which wipes down the whole thing. And then it runs an acceptance test, and then for the next test, it will do exactly the same. Since we're doing that, if you're trying to work, forget about it. So the fact that you've got two means you can concentrate on 3,000 and 8,000 and just do the test.
So that page there, the test coverage page,
Yep.
is that only available on from the testing,
Correct.
not from the live?
Exactly.
application?
Yeah, because basically on the testing application, what we also do is we instrument the code every time you save the file. So every time you save a file, it instruments the whole code base and it runs that instrumented code. So the main app is completely untouched.
So Sam, the strategy is that you blow away, let's say you save right in the middle of the test run. You just stop or do you finish?
No, it'll finish whatever you're doing there, and it probably won't run until the next time. So
Oh, I see.
pull requests are welcome if you want to fix that.
Yeah, fixing that for Meteor Run was a minor issue.
Right.
I think we got it.
What, so that when you save midway, while it's trying to do something, while it's trying to compile?
Yeah, it has to use a combination of like looking at modification times and hashes and
Right.
making and a bunch of stuff. It does work now.
It's probably not that important, to be honest, because by the next time you save, it's going to run them anyway. So it's like one save later is probably not a big deal.
So if you're stubbing out these things in Meteor that you don't really control, right, and then Meteor upgrades and all the actual objects change, but your stubs don't.
Yeah.
Your tests are happy, but
Yeah.
your applications
I mean, yeah, we'd have to go back and update some of the stubs, basically. If we upgrade the app, and then you have to also change some of the stubs. Chances are you'll get a few changes, you won't get fundamental changes that break the whole thing. And the other thing to note is this fully running app is not stubbed out. This is a full Meteor app. The stubbing only happens at the unit test. And I've also found, because of the combined coverage, most of our tests are actually acceptance tests. There's only a few unit tests where we need high levels of permutations. So that's where you don't really want to use an acceptance test. Anything else? All right, thank you very much.